Hey team, so I'm going to go over these last two past paper questions that I haven't done yet from your notes. Sorry about yawn. And then I'm going to give you some examples to try just to finish exponentials and logs, and then we'll start a circle on a Friday. Final topic, how exciting. So simplify the expression 3 log 2e to the base e minus 2 log 3e to the base e. Give me your answer in the form. So remember when they give you something like this, it's to try and give you a bit of a hint to like how your answer is going to look and obviously lead you down that sort of path. So first thing we're going to do, obviously we are thinking about log rules when we're simplifying expressions. So we are going to bring our powers up. So when we bring, when you bring your powers up, now the thing you need to watch out for is that whole thing is going to be to the power of 3 minus this whole thing squared. Okay, so apply both of them, kind of like your indices rules from Nat 5. Now at this point, there's multiple ways you can go about this. What I'm going to do is, I think probably what you might think about is taking away means you divide. So I'm going to use that method. There's another way of doing it that I'll talk to you about just at the end. But I'm going to think, right, well, take away means divide. So what I've really got is this 8e cubed over 9e squared. Okay, now that obviously does simplify down because your e's are going to cancel down to just an e. At this point, if we draw our attention back to this line here, we're thinking about, okay, how are we going to get from there to there? So they've got some number plus something, take away something. Now, if we think about it, what you've really got is 8 divided by 9 times by e. Now, if you work backwards from your log rules, so log e to the 8, when you divide, you take away. And multiply, you add. That last term we know is 1. So now what we've got, if I just put it in the right order, that matches, we've got 1 plus log e to the 8 minus log e to the 9. So it's all about using your log rules in the kind of best way that makes sense. Now what I could have done is from this line here, which again, it might not become instinctive to you, but I'm going to do it anyway because some of you might have thought it, is like we do in when we were doing from experimental data and we're working backwards, you're like splitting it back up again. So for that first term, 8e cubed, because they're multiplying, you might be like, oh, that means they're adding. So what I could do is have log, I'll just stick with it in blue. So log e to the 8 plus log e to the e cubed. And then I'm minusing, and again, do the same thing with that and split it up. If you don't like this method, don't worry about it. And then again, you can see I've got my log e to the 8 minus log e to the 9, like I know the answer is. Again, there's two ways you could go about it. You're taking them both away. When you take away, you divide, you can bring them terms together. What you also could do is bring the powers to the front. If you bring your powers to your front of this term and this term, then you're left with that log e to the e, which disappears, and ultimately you get 3 minus 2, which is where that 1 comes from. So again, there can be multiple ways of doing something. If I just complete this question by at least getting rid of the negative. So again, your two options are to combine these two together. You're taking away, you divide, e cubed over e squared is e, log e to the base e is 1, or you can bring your powers back down again, and then the log e to the base e will disappear because it's obviously 1, and 3 take away 2 gives you the 1. But again, you can see that that's where this answer comes from, of 1 plus log e to the 8 minus log e to the 9. That's an e. Right, second example. So this is similar to what we just covered last week. But the ones we were doing, they gave you the graph, obviously, and they gave you the graph, they gave you the gradient, or they gave you points that you're grading, they gave you the y-intercept, and they asked you to, therefore, figure out what different letters were, like M and K, for instance. This one is similar, but obviously it's asked in a slightly different way. because they actually give you the final answer. So it says 2 variables, x and y, satisfy the equation y equals 3 bracket 4 to the power of x. A graph is drawn of log y to the base 10 against x. Show that its equation will be of the form this and state the gradient and y-intercept of this line. So, as we did with the other questions, obviously they gave you like n k to the power of x, for instance. We introduced logs on both sides. They are telling you it's log to the base 10. So I'm going to do that from what I'm starting with. So I'm going to introduce logs on both sides. So log 10y is log. So it's all about, see when they ask you something in a slightly different way, you just need to have that confidence and say, okay, what do I normally do, right? What question do I normally associate with this? And you do it. The next step, obviously what we do, and then we said like every step basically the same, is you split that back up. They are multiplying, so we're going to split it back up and add them. Okay, what do we do next? Right, well, ideally, you know this, it represents a straight line. So we want to have something x in it, so bring your x down. And then I'm going to put it in the form that you want, which is you want your something x at the front. So I'm going to move that number to the front. Just put a wee bracket. X plus that. And remember, that is your gradient. So this is y equals mx plus c. Again, what's different about this question here is, you know, we're not having to therefore do a bit of kind of changing between a log and an exponential to work out the answer. So that's your gradient. Just use that. That's your c. So we can just state straight away, okay, the gradient is log 10, well, log 4 to the base 10. And your y-intercept is that. Now, you would actually get answers for this, but this you can work out as a numerical answer. If you take your calculator, log is already in base 10, so ln is base e, log is already base 10. So if you do log 4, you get 0.60 technically if I go to 2 decimal places. And then if I do log 3, you get 0.47. Well, 0.48, sorry. So yes, it's basically what you were practicing last week, which we got, slightly different context, but just thinking, what do I normally do? Apply logs on both sides, work one way through it using your log rules but in reverse, and then again, you're matching up what is what in this case. So that's the final 2 past paper questions, and I'll give you some questions to try.